Welcome to the electronicshobbyblog.com. I love my Raspberry Pi 3 Model B, both as a desktop Linux machine and as a Commodore Amiga emulator. But I got tired of it sliding around on my desk every time I moved a cable or bumped into it. When I found this Rosewill Mini ATX case sporting two fans, one with a blue LED, on Amazon for $20 delivered, I decided to put my Pi in a case. Now that may seem like an easy task, just drill a couple of holes and bolt it in. But it's actually not that easy if you want to try and get all of the buttons, switches, and ports working as they're supposed to. The soft power switch actually commands the Raspberry Pi to start up and to go into its shutdown sequence. The reset button performs a hard reset if the Pi gets locked up. Both USB ports are brought out from the Pi to the front panel, and so is the headset jack. Around back, I've added a custom panel that includes an audio jack and a USB port and HDMI connector. Now the tower can sit under my desk and connect to my computer, and I can simply use an HDMI switch to switch between the two. So follow along with me and I'll show you how I did it. The first thing I had to do was to make sure I had sufficient power for both the Pi and the 12-volt fans. So I started by installing a power strip here where the motherboard would normally mount. And I have the cord exiting out the back where the motherboard's connector panel would go. The Raspberry Pi itself requires 5 volts and about 2.5 amps. If you order a kit, you normally get a 5 volt, 2.5 amp wall supply. I wanted to make sure that I had enough power for expansion and to run all of the USB ports at one time. So I went on Amazon and I found a 5 volt, 3 amp wall transformer that had a micro USB connector and could simply plug into the Pi to power it. Here it is, right here. The fans require 12 volts and about 100 milliamps apiece, including the LEDs. So I purchased a 12 volt, 1 amp wall transformer. Actually, Amazon had 6 for $14, and so I've got plenty left over for future projects. Here's that one, right here. They're simply plugged into the power strip that I've installed in the case. The next step was to get the soft power switch working, along with the power LED. The soft power switch included in the case is actually a momentary on-off switch. And so when you press it, it basically shorts the switch, and when you release it, it opens the circuit. The Raspberry Pi can be commanded to start up and shut down when there's a momentary short between pins 5 and 6 on the Raspberry Pi's onboard GPIO connector. To do that, you just need to connect the switch between pins 5 and 6 on the connector and then modify the config.txt file that's found in the boot directory. The actual command to instruct the Pi to start or shut down on a short across pins 5 and 6 is dt overlay equals GPIO equals shutdown. Keep in mind that these commands work with the Raspberry Pi Model 3. Earlier versions of the Raspberry Pi use different syntax. You can still do this with an earlier Raspberry Pi, but you'll need to search the internet to find the correct commands. The next step was to get the power LED to properly display the status of the Pi. You can use the config.txt file to set the status of GPIO pins on startup and shutdown as well. You need to pick a specific pin to control the power light. In this case, I picked GPIO 27, which is physical pin 13, and the ground pin directly across from it, which is physical pin 14. This makes it easy to just plug the 2-pin connector into the board spanning these 2 pins. And then to get the light to function, I went back into the config.txt file and added the following lines. The first line, GPIO equals 27 equals OP, sets GPI 27 to be an output pin. The next command, GPIO equals 27 equals DH, sets GPIO pin 27 to a digital high, and that turns the light on. There's no need to turn it off because when the Pi shuts down, it automatically turns off all of the pins. I also got the hard disk activity light to flash whenever the Raspberry Pi is accessing the SD card. And I did that by redirecting the Raspberry Pi's SD activity light to a specific GPIO pin. And then that GPIO pin is connected to the LED. I picked GPIO 13, which is physical pin 33. And for the ground, I picked the pin directly across from it, which is physical pin 34. Then I went back into the config file and made the following changes. The command to redirect the activity light to that specific pin is DT overlay equals pi3-ACT for activity -LED dot GPIO 13. The reset switch was fairly easy, providing you don't mind soldering on your Pi board. There are actually two holes that are unpopulated where the reset function can be accessed. All you need to do is solder a 2-pin header to those two holes, and then you can connect the reset switch directly across that header. Now keep in mind that you're performing a hard reset. It's the same as if you unplugged the Pi and plugged it back in. So you need to be careful and only do that if the Pi is locked up, or you run the risk of data loss. The Raspberry Pi Model 3 has 4 USB connections on the board. This case had 2 in the front and I added 1 in the back. I brought out each of the 3 USB ports independently from one of the onboard ports. That ensures that I've got full access to all of the power that that USB port can provide. If I simply wired everything together, I would be extremely power limited at the USB ports. I found some old USB cables and I cut the ends off and then spliced those to the internal motherboard connection for the USB ports in the case. Here you can see that connection. This single wire actually had 2 sets of 4 wires in it, each one leading to one of the USB ports. The next step was to bring the audio out from the Raspberry Pi board to the front headset connector and the audio jack that I added at the rear. This case was equipped with both an HD audio and AC97 connector. I was really only interested in connecting the headset jack, so I found an old wire with a 3.5mm plug and cut the end off. I spliced the left and right audio signals and the ground to that wire, and that wire plugs directly in to the Raspberry Pi. The fans were probably the biggest challenge. Since they're 12 volts, and the Raspberry Pi can only put out 3.3 volts at its GPIO header with fairly low current, I needed to build a custom controller using a MOSFET. Here's the circuit diagram. When the Raspberry Pi pin goes high, it turns on the MOSFET and current can flow through the fans. I really didn't bother with any kind of speed control. When the Pi comes on, the fans and associated LED come on, and when the Pi shuts down, the fans go off. The code is exactly the same as it was for the power LED. In this case, we specified GPIO 5, which is physical pin 29, and we use the ground pin across from it, physical pin 30. After that, I drilled a few holes, secured everything in the case, closed it up, hooked it up to my system, and I was ready to enjoy some retro gaming. Well, I hope that will inspire you to put your own Raspberry Pi in a mini tower case. If you enjoyed that, then please give me a thumbs up and subscribe so you'll see the new content. Till then, cheers. I've got some retro gaming to do.